So I've got an Excel sheet set up here, and I want to do some. First, I want to do some one-dimensional basic image processing. So what we're gonna do is I've got an input array of pixel data, and they can range anywhere from 0 to really 255. So 0 is the lightest, 255 is the darkest. And then I've got something set up for my processed image, or what the output of whatever I'm doing is. I've got a spot to look at or input my kernel, which is really doing the process, and then a scalar, which is just kind of keeping things in a reasonable range. So first, let's just say we've got an image like this. 150, 150, 150. So we've kind of just got like this block that's sitting here. Maybe this is an obstruction, or it could be anything really. And right now, our process image doesn't have anything because I haven't quote unquote programmed it yet. So let's program it. The first thing we want to do is we'll just come up with the formula for just this cell, and then we'll push it to the rest of them. The reason I'm not doing this cell, or this pixel, is because that would be based off this pixel right here, and we need the information for both of its neighbors. So that means this pixel and this pixel. And of course, we don't have data for this pixel. So that means there's a few things that we can do here, but for this case, I'm just going to always leave the most edge ones at 0, or sometimes you might want to have them at 255. Doesn't really matter. Well, it might matter, but for this case, it doesn't matter. So that's why we're starting with not the first pixel, but the second pixel. And so let's put an equals in here saying we want to do a formula. And we're going to say this pixel times its cell in the kernel, which is right here for this case. And also, we want to put some dollar signs in here for the kernel, because as we apply this formula to other spots, it's going to drag the cell references across here. But we want the kernel to always stay right there. And now our center pixel times the center cell in the kernel. We want that to stay static, so we're going to put some dollar signs in there. And then this pixel times this cell. Once again, we want it to stay static. And then the whole thing I want to put in parentheses and multiply by this scalar. Now this scalar, that just kind of keeps things in a reasonable range. All right. So no surprise, we've got 0 times 0 plus 0 times 1 plus 0 times 0. So it just turns out to be 0. But now let's do something interesting. Let's just take this and apply that formula to the last 6 pixels here, or I guess the rest of the 5. So the kernel we have right now is called the identity kernel. And so it means what our input is just our output. So you can see we just take this and it directly kind of shoots it out there. So this is, using the identity kernel is a very useful thing to make sure you've got everything set up right. If you don't get out what you put in, it means that there's probably some sort of programming error. This appears to be working well. And you can see I've got my plot down here of my input image and my output image, and you can see they kind of match. And this can kind of help you visualize what these things are doing are truly like filters: low pass filtering, high pass filter, etc. So speaking of a filter, let's do something first that's a low pass filter, or in imaging we normally call that a blur. And so what we expect is this kind of has some sharp edges, and we expect to see a blurred image to kind of have it dampened or kind of smoothed out. So turns out the filter for that, there's a couple ways you can apply it, but we're just going to do 1, 2, 1. and we need to change our scalar here to 0.25. Now, we can see that our center still stays the same color, but we've also kind of got our color leaking out into this white and the white leaking into the gray. And so it's created this kind of blurred image. And if you look at the plot, you can also see how it's kind of smoothed things out. Let's try a different filter. Let's see if we can find the left edge of this object or this picture, right? So we want to use a left Sobel filter. So I'm going to do a -1, 0, 1. And I'm going to change my scalar to 0.5. Maybe it can actually be 1. Yep. So the scalar that I'm messing with, I'm not really going to get into how you can figure out what these scalars are mathematically, but it's something to do with the values in this function and the max values that you might expect for your pixel data. But for this example, we'll just kind of tweak it until it looks right. So anyway, we've got our input here, and we've got our output here. And let's see if we can kind of interpret what it means. Well, how we interpret it is, what we get kind of might depend on how we interpret it. So here we see that we've got 150 for this pixel and this pixel. So that's kind of in this range right here. And so this is the left edge, right? This is the left edge. The area in between these two pixels is the left edge. And so that means this black is kind of highlighting where our left edge is. So we'd expect that if I make this object get a little bit bigger, let's say that it's actually moving, so everything's shifting over this way, say it's like a video. So that means we lose this guy here, and we gain this guy here. So now we can see that it's tracking that edge, and it's shifting over. Or even if it were to grow, right? Even if it were to grow, that edge is still staying in the same spot. So those are just a few things that you can experiment with or apply to a 1D, but it's much more exciting when we start doing things with two-dimensional images.